Hello, this short video is the very first lesson in Unit 3, which is adding and subtracting polynomials. This lesson has a lot of vocab that you're going to need to know in order to kind of understand this unit, sense it up. The first thing is a monomial. A monomial is a single term expression. So it can be a constant, it can be a product of numbers, it can be one or more variables. So for example, the number 13. 2x squared. Negative x to the third times y times n to the fourth. There is nothing being added or subtracted. So there's not the operation adding and subtracting. It's a single term. That's a monomial. A polynomial is when you take these monomials and you add and subtract them together. So you combine them. So for example, x plus 1. Negative 3x squared plus 2x plus 1. These are all examples of polynomials. So anytime you have an addition or subtraction, that is what we consider a polynomial. We are then going to go ahead and we're going to learn how to classify these and write these in standard form. Then the second half of the video will be learning how to add and subtract them. So first off, standard form. Standard form is when the terms of the polynomial are in descending order, meaning the greatest exponent is listed first. So it goes from basically greatest to least, or biggest to smallest. So if you're looking at some of these, some examples, 7 plus 2x squared, we're looking at the exponent of our terms in there. So the exponents go from greatest to least. So since this is 2x squared and the 7 doesn't have an exponent, 2x squared needs to come first. So we're just going to switch those and rewrite as 2x squared plus 7. The next one, 6x squared plus x to the third. We have a 3 and we have a 2. Remember, it's going from biggest to smallest, so again, switch them. We keep all the signs the same, nothing else is changing. We're just rewriting it to go from greatest to least. And you'll see why when we're doing this in just a minute when we begin to classify them. 9 plus x minus 4x squared. Same thing. We have a 2. Remember, if there's not an exponent there, it's still a 1. The 9 doesn't have a variable. So we need to write this as negative 4x squared plus x plus 9. And then I have 2 more examples there. So just remember standard form, greatest to least. I can't repeat that enough. Greatest to least on those exponents. Okay, classifying polynomials. Here, we write in standard form, that way it's very easy to classify. We can look at it, we know exactly what type of graph it would be if we were graphing it. We know, what kind of equation. We can tell a lot when they're written in standard form. So it's just kind of the way to keep everything consistent. This chart you can find in your book, so this blue chart down here, and page, I'll tell you, page 475. So I'll write that in here. So page 475, and this would probably be a good thing I would copy and I would keep in my notes. So if you have a constant, so when you classify, let me back up for a second. You are classifying by the degree of the polynomial and the number of terms. So basically, remember your degree of that exponent, and then your terms is the number of things you are adding and subtracting together. So if you look at this chart, you'll see, okay, if we have just a constant, it's called a constant. It's just one term, nothing's being added or subtracted, and we call that a monomial. 5x plus 9. The degree is 1 because if I had an exponent, it would be 1. If I have a degree of 1, that is a linear equation. So basically that means if I graphed it, it would be a straight line. And there are 2 terms because there are 2 things being added or subtracted together. When there's 2, it's binomial. Okay, the next one, 4x squared plus 7x plus 3. My highest degree is 2. If my degree is 2, that's a quadratic. Again, if we graphed it, that would be that U-shaped graph we've talked a little about. We haven't really gotten into it yet. Number of terms, there are 3 things being added together, so this is a trinomial. So you can probably see a trend here, monomial, binomial, trinomial, and then take you up to this box up here. Kind of a little trick. I like to try to remember these. Put it in terms of bicycles, tricycles. I know a lot of times you guys call it a unicycle, but it's also a monocycle. It just has one wheel. So that's how we can kind of remember by the number of terms. So let's do some examples. Let's try and fill in this chart over here. 4x plus 3. How many, or what is its highest degree? Well, its highest degree is a 1. So this would be a linear. And then how many terms are being added or subtracted? Well, there's 2 terms. So this would be binomial. I'm going to abbreviate here, sorry. Okay, so x squared plus 6. This has a degree of 2, making it a quadratic. And there's 2 terms, so again, it would be a binomial. The next one, there are 3 terms being added or subtracted together, so it's a trinomial. Its highest exponent is a 2, so that's a quadratic. And again, use that chart. You know, especially as we're just starting and learning, it's okay. You know, use it, take advantage of it. The next one, let's see. X to the third plus 2x minus 2, there's 3 terms. So again, it's a trinomial because there's 3 things being added or subtracted together. That exponent is 3, so it would be cubic. Last one, x to the third plus 4. There's 2 terms being added together, so it's a binomial. And its highest degree is 3, making it a cubic. So here's some good practice right there. All right, so let's get into it. Adding and subtracting polynomials. When adding and subtracting polynomials, what you're doing is basically you're adding like terms. Remember, like terms are those variables are the same. So it's kind of like you can't add apples and bananas. You add apples to apples, bananas, bananas. You can't add them together. So the first thing we're going to do is if there's parentheses, we're going to remove the parentheses. We're going to group the like terms. So what that means is if you're looking at the example here in step 2, I put my x's together and my y's together. That way it's easy for me when I'm going across. I can easily see, okay, I have 12x plus 23x. I have 35x's, a 10y, and then negative 16y. I have negative 6y. So it makes it really easy for me to write or to combine my like terms. And then lastly, I write it in standard form if it is not already in standard form. Okay, so let's do some examples. So simplify, and my first one is 12y to the third plus y squared minus 8y plus 3 plus 6y to the third minus 13y plus 5. So if I rewrote this, I would just drop the parentheses. There's nothing I need to distribute. It's just plain adding and a subtraction in there. Next thing I'm going to do is I'm going to try and color code here. So I'm going to write it with my like terms next to each other. So I'm going to do 12y to the third plus 6y to the third. Next, I have y squared terms, and I only have 1, so plus y squared. I then can go ahead and I have y terms. Notice I am keeping the operation of what is right in front of them. So negative 8y minus 13y. And lastly, my constants, plus 3 and a plus 5. So plus 3, plus 5. So now I go ahead and I just combined my like terms. So 12y to the third plus 6y to the third. That's essentially telling me I have 12y to the thirds and then 6y to the thirds. So altogether, I have 18y to the thirds. Notice, I did not change the exponent. Those stay constant. All I'm doing is adding those coefficients out in front. Y squared, I'm not adding or subtracting anything to it, so I just put y squared. I have negative 8y minus 13y. So I have a negative 8 minus 13, or a negative 21. So negative 21, and again, I keep it just y. I don't do anything with that. And lastly, plus 3 plus 5, or plus 8. I then double check, is it written in standard form? This time it is. I have my greatest exponent, or my greatest degree, excuse me, which is to the power of 3, and then it goes to the power of 2, 1, nothing. So I'm good. That would be my final answer. That's as far as I can go. There is nothing else I can add, or let's try another one. 7y to the third plus 2y squared minus 5y plus 9 minus the quantity of y to the third minus y squared plus y minus 6. This time, I am going to rewrite because I'm going to use my little trick. I'm going to change that into plus, and when I do that, all of these signs switch. So I'm distributing that negative or that subtraction to every single term inside those parentheses. So if I rewrite this, I didn't do anything with those first parentheses. I'll keep as is. But my second set of parentheses, I'm going to have plus a negative y to the third plus y squared minus, or I'm going to put, I guess I'll put plus negative y plus 6. I'll keep it consistent. Now, let's rewrite with like terms together. So a 7y to the third, and I have a negative 1 over here. So 7y to the third plus a negative y to the third. All right, let's go my y squareds. So color coding is just a technique I use. It kind of helps me keep everything the same. So it's a trick you might want to try, but you don't have to. All right, and now I have my y, so I have a minus 5y here, and then a minus y over here. So let's see, minus 5y, a negative y, and lastly my coefficient, or excuse me, my constants. Oh, I lost my thing. Where is it? There it is. And then a 9 and a 6. So plus 9 plus 6. All right, so now I can go ahead and simplify. So by combining my like terms, so 7y to the third minus a y to the third, or 6y to the third. 2y squared plus y squared gives me 3y squared. Negative 5y minus y, 6y. So be very, very careful of your signs, guys. 9 plus 6 is 15. Lastly, double check, is it in standard form? It is. My degrees are going from greatest to least, so I'm good. All right, I'm going to go ahead. I'm going to have you pause the video for a minute. Go ahead, try number 3 on your own. Press play when you're ready to see the answer, and check yourself. All right, the answer to this one, you should have got 6x to the 5th minus 4x to the 4th plus 3x to the 3rd plus 2x squared minus 7x minus 17. So you should have noticed this one, there wasn't actually very much to combine together, but you did at the end have to rearrange it to be in standard form. These are going to take practice, just like those exponent rules like last unit. You will get the hang of them. We'll do a lot together, but if you have questions, you need extra help, please don't hesitate to reach out to your teacher.